Welcome to qnawire.
Our question wants us to find the change in the magnetic field with respect to the z-axis, dB/dz, as this mass of silver atoms is traveling through a distance of 1 meter, so that it's our x direction, at a speed of 100 meters per second. So it gets deflected as it's traveling through this 1.0 meters in the z direction. Well, our delta z value, by definition, is going to be 1/2 times the acceleration in the z direction times the time in which it's accelerating squared, because there's no initial acceleration or velocity in the z direction. So all of that deflection, all that delta z value is going to come from that acceleration. Well, the question is, okay, well, how can we relate this acceleration to the force in the z direction in the equation that we're given, where it's equal to mu sub z, which is the magnetic moment. It's just a constant. You can look it up. It comes from the charge of the electron times Planck's constant divided by 2 times the mass of the electron. Comes out to be 9.26 times 10 to the minus 24. That's a constant you can look up. So we're going to use the fact that force is also equal to mass times acceleration, where mass here is the mass of the silver. The mass of silver, since considering this to just be the nucleus, is going to come from the atomic number of silver, 100 times the proton, m sub p, in units of kilograms. The only other thing we don't know, so now we could plug in delta z and we could solve for a sub z, right? A sub z is just going to be f of z over m, right? So now we have delta z is equal to 1/2 times f of z over m times the time squared. What's the time? We know what the time is because we know how long it's going through this 1 meter distance, or how fast it's going through this 1 meter distance. Since velocity is distance divided by time, time is distance divided by velocity. So this is x over v of x squared. Replace f of z with mu of z dB/dz and solve, because we know everything else in this equation. So we can go ahead and do that. We find that dB/dz equal to, so dB/dz is on top over here. So we're solving for dB/dz. So we have delta z is equal to 1/2 dB/dz mu of z divided by m times x over v of x squared. Therefore, dB/dz comes out to equal 2 times delta z, right? So get rid of that 1/2. The mass, it has to be multiplied by both sides to get rid of the mass on the bottom on the right side. So this multiplied by the mass. Mu of z is in the numerator on the right side, so it goes in the denominator. So mu of z. And then v of x, or x over v of x, is going to become inverted. So you end up with x squared on top and x squared on bottom. Plugging in these values, with this comes out equals 0.389 Tesla per meter. We have unit Tesla per meter because the magnetic field has units of Tesla and Z has units of meters, right? So dB/dz would be Tesla per meter.